So we keep solving physics GRE. So the problem 40. Okay, so this problem is very common in the, if you go to see the 2012 question, you will see exactly similar question. So what experiment counted about radical? So every case, every time you say the GRE, say that the radiative process, what you need to think is a Poisson distribution. Okay, so fortunately you don't have to remember this, but I remember this. So the Poisson process basically counts how many times it happens, and basically this lambda is the average, and the random variable well contains the contains 0 to infinity, so you can easily check this. If you sum over possible probability, then it will be 1. So this is the discrete probability distribution, and then you can use to find the average, called expectation value. Basically you can show this is I think it's lambda, and the variance, not variance, standard deviation basically is square root of lambda, and the variance is also lambda. Okay, so it tells you that the average is 9934. So basically we can count as 10,000, right? And the count rate and what is standard deviation, right? So it's just take a square root of this lambda. So the answer is 100. Answer is A. So this you need to remember, especially the Poisson distribution. By the way, to prove this too, is simple. You just follow from the definition. Basically, when you prove it, you will need Tyler expectation values for the property of Tyler expansion. Okay, and 41 is also ask about which one is largest binding energy. The answer is Fe. The answer is ion. So this question is exactly the same as some question in the 2012 physics GRE. So you need to remember the answer. The famous largest binding energy is for nucleon is the ion. It's the ion. So 41 is asked about somehow the common sense. Okay, so 42. Proton beams incident on status was 0.1 centimeter thick, and the scattering contains the 10 to the 30 target nuclei at per cubic centimeters, and has one proton per incident median is scattered. The scattered cross section. Nice. Very difficult. That maybe everybody know. Forget about the cross section. Okay, so somehow when you see this kind of equation, then the easiest way is you just write down all the parameters you have. Okay, so we have a t, which is 0.1 centimeters. Okay, and basically then there's a 10 to the negative 6 per particle scatter. So there's basically no unit for this. Okay, there's also 10 to the 20. This is the density, right? So basically, it's the 10 to the 20 nuclei to the cube, 1 over cm3. Okay. So what is the cross section? So remember the cross section is area, right? So all we need to know is to find which one is the how to form a combination of the areas of the unit of area. So what is the unit of area? Centimeter square, right? Then it already tell you the answer, right? Because this is 1 centimeter, this is centimeter square, right? So basically, if I use this t times this, then I get this one. And then for one proton per incident, there are 1 proton per incident median is scattered. So it tells you that you should use this one divided by this one, right? Then this is what you want to say, the scattering cross section. Because it asks you about basically when you use this divided by this, you get this one, and the unit is basically cm squared, then which is what we want, right? Oh no, sorry, 6 minus 6 minus 19, yes, it's minus 25. Okay, so we know the answer should be C. Is it C? Let me see. Yes, so the answer should be C. Okay, so you can use, so basically the ordinary unit analysis or dimension analysis is also important. Okay. 23. Oh, nice. There are 2 springs. Okay. And the normal, longitudinal normal. Okay, so basically, if you are good at mechanics, then you can write down the Lagrangian and solve it. The good thing is that I will not do this. Okay. Because this question just tell you about what is the ask you about what is the motion, the equation of motion should look like. Okay, so there are so first we want to ask is how many normal modes it has. How many normal modes? So remember that basically B is the center of mass. B is the center of mass, right? So the center of the mass should be will be fixed in here. So actually you only have 2 degree of freedom, so you have 2 normal modes. So 2 more modes has, so there 1 normal mode is they A and C move together, move the same directions, and another is they move with out of phase, or they move different directions. Okay, so the A said the A, B, C all move in the same direction. Oh, this is because I already said B is the center of mass, right? So A is not impossible. And AC moving opposite directions, we call amplitude, and B at rest. And C said that AC moving in the same directions and B moving in the opposite, so B, C is wrong. And AC moving in the same direction and B moving in the opposite, also wrong. So what you have is what the remaining is what? So remaining is B and E. The remaining is B and E. So now the problem is which one is correct? Is B, C moving in opposite directions with equal amplitude will give you this frequency, and this is the remaining what we need to find. So remember that if you have a single M, then you will have this one. Right. So this tells you that it looks like there is a single mode. There's a single mode. So the single mode tells you that these 2 should move out of phase, because it looks like this one is basically the wall, and then there's a spring here and oscillate, and there another one is basically the opposite directions. So once you notice that, you can see, oh, basically it's like a single mass moving. So the answer is B. Because they're moving at equal amplitude, so the mass can be fixed. Okay, so the answer is B. Okay. Okay, so 44. So say that there's a MV and hit the stick, and ask you about frictionness, and ask you about the speed of V. of the center of mass of a stick after collision. So remember that once it hits, right? It said that the perpendicular to the stick that intersect the stick at one end as shown as after collision, which is elastic, and the particle is at rest. Okay, so you have this kind of information. And usually collision we have two formula we can use. One is the momentum conservation, one is the energy conservation. Okay, in this question, what we need is what? Is the momentum conservation, because it's about velocity. So we have this, the original momentum, plus m times 0, because it's larger and does not, right? Equals to what? The particle is elastic and the particle is at rest. 0 times n, the final velocity. So final velocity just m over small m divided by large m n times v. So the answer is A. The answer is A. So elastic is the important properties, and they said that the particle is at rest. Tell you this information, then you can get the answer. So it's very easy. So for you, a photon wavelength scatter elastic on the free particle initially at rest, and wavelength is photon scatter what? Okay, so what is the 45 I want to ask? What is the 45 I want to ask? So basically, when the photon hit the electron, basically you need to use what? The Compton scattering, right? So I already say in other video that the Compton scattering, this formula is very, very important, because you can see in 2012 GRE they actually just ask you about how to they just give you 5 questions and ask you which one is correct. So you need to remember this formula. Okay, so the cosine is 90, right? So this lambda prime equals lambda plus HMEC. This, right? So what is the answer? What is the delta lambda? The answer is obvious, right? The answer is obvious. But the difference is that the elastic on the free photons, not electron, right? So we need to change this ME to MP, But all the process is the same, right? So the answer is this one. The answer is D. Basically, it's just some variance of the Compton scattering. Basically, photon scattering with some free charge particles. And this is the answer. Actually, it's photon scattering with some rest particle. Then done. Photon hits with some rest particle, and then you just use the momentum conservation and energy conservation and special relativity, and you can get the answer. Okay, so the answer is D. Okay, that's it, and I will see you guys in the next video.